Roger Marran will present a new technology that his company Energy Kinetics invented.
Great. Thank you, Florian, and good morning and good afternoon to everyone. So my speech here, I'm Roger Marran, president of Energy Kinetics. So we're a manufacturer of high efficiency heat and hot water systems with a focus on boilers. So on my talk here today, I'll dive into some details in this area. The first, let me see. My slide is not advancing. There we go. It was just delayed. Okay. So the first thing is I'd like to touch upon is an integrated approach to providing solutions to climate actions. We've discussed fuels and many proven and promising solutions throughout the Eurofuel NORA Technology Conference. I'd like to introduce also, as we've touched upon in several cases, energy efficiency and how it can play a powerful role too. So in the US, we've had remarkable results since the 1970s with drastic fuel reductions on a per household basis through today. So I think those can continue with the opportunities we have with technology. So available boilers can cut energy use further while providing the same and better comfort and comparable or better hot water as well. I think we can modernize boilers to compete with all fuels. So it doesn't matter if it's electric, gas, you name it. And then better performance and competitive pricing can satisfy market demand as well. So when those come together, I think we have a winning combination. So the first thing I'll dive into is a little bit about the AFUE and the Department of Energy and some changes there. So going into January 21, oil-fired hot water boilers currently have an AFUE rating of 84 as the minimum, and that's going to go up to 86. And also on oil-fired steam boilers, it's going to go from 82 currently, and that'll move up to 85. So that's a general move that's right around the corner. The couple things to look at relative to AFUE is that boilers actually offer much greater savings than can be determined by AFUE alone. So from studies, several of them, but also from Brookhaven National Labs and the performance of integrated hydronic heating systems, there's several things that really tie in to say that the opportunity to save is much better. But first, AFUE does not apply to heat and hot water systems. Also, the test procedure actually requires all controls to be disconnected. So oddly, you have better controls. The first step in the procedure is disconnect them and don't use them. The other one is AFUE virtually ignores idle loss, as Dr. Butcher referenced. Idle loss in small loads is very critical to high efficiency. So that's also virtually ignored. AFUE also doesn't address distribution efficiency. It's an appliance standard, so it doesn't really go beyond the appliance. And in the study from Brookhaven National Labs, it showed that an 87.5 AFUE oil boiler achieved higher annual efficiency than a 95 AFUE ModCon gas boiler. So at 87.5 AFUE with the right controls and design, it actually uses less energy on an annual basis than the top rated modulating condensing boiler that was done on the market at the time. Also, over other boilers, it shows up to 38% savings are possible. So really dramatic results there. In other areas on furnaces, AFUE 2 is in review, and this is just for furnaces again, so forced air systems. So currently there are 3 metrics for furnaces: furnace fuel consumption, fan power, and standby and off mode power consumption. So instead of using 3 metrics, AFUE 2 would combine those into a simple 1 metric standard. So that should be easier to understand. That's the concept. Although in combining those, there is up to a 3% backslide. So if the same appliance is rated today with AFUE and tomorrow with AFUE 2, it may actually look like it's 3% less efficient, even though it's the exact same appliance. So it's something to see what develops in that in the future. There have been many discussions on that standard. The next topic that I dive into here is with our technology strategy and alignment with the NORA grant and NYSERDA. So we had an understanding of NORA's goals and focus on underserved areas of the liquid fuels market, and that helped us align Energy Kinetics technology strategy with a tankless coil replacement boiler design that helps improve the image and performance and the opportunity in our industry. NORA leadership encouraged us to apply for the grant and to make a more efficient and cost competitive design that provides more hot water. So we've talked about some great technology from Europe and from the US, but tankless coils are on the other end of the scale. So tankless coil boilers really reflect poorly on the industry for several reasons. They have poor efficiency, as Dr. Butcher showed in some of his hot water efficiency charts. They have poor hot water volume and temperature control, so not only low efficiency, but they don't do a good job of providing hot water. And they have noisy operation as well. I feel that all these items are solvable product problems, not fuel problems. And on top of that, tankless coil boilers are estimated to be about 50% of the installed base and about 50% of the replacement boilers in the US. So a very big market opportunity in the US for that. Although our boiler business is not as big as Europe, it's for what we do look at as a significant opportunity to do much better. Let's see. So with the grant that we applied for with NORA and NYSERDA, we spent several years developing a cost-competitive solution. So that solution is the Ascent Combi boiler, and we'll discuss that one today. And we'll also touch upon what we call the Ascent Plus Combi boiler, which has greater efficiency and it vents with polypropylene, either sidewall or flex through the chimney. So here are shots of a couple boilers. So the one is the Ascent Combi, which is 87 AFUE. And again, AFUE is based on the higher heating value. And we introduced that in 2017. So that's vents through a conventional chimney, either terracotta or stainless steel flexible liner in the chimney. And then last year we introduced up to a 91.3 AFUE. It's the Ascent Plus Combi. And that one uses dilution air. It's non-condensing and it vents through polypropylene. So it solves some of the market problems for aging chimneys and gives you much better flexible vent solutions for the market. So these are some of the design pillars for the Ascent Combi that we established with NORA and NYSERDA. We wanted a competitive price, wanted a familiar burner and control, so it would be accepted well by technicians as well as installers. We wanted a drop-in replacement for tankless coil boilers. We wanted to have significant savings, so 20% savings is the target over tankless coil boilers. We wanted better hot water temperature control and comfort. We really wanted to make sure that it satisfied consumer needs that way. Wanted a long life pressure vessel, and we also wanted hard water serviceability. We also put in a few options. So one of them was a very quiet operation with a silent burner cover. As you see, there's a cover on the burner on this unit to keep it very quiet. And we also have several hot water operating modes that match use patterns. And so those use patterns allow it to match the consumer's needs as well as save even more energy. So putting this together, there were several keys to successful performance. So the plate heat exchanger and a low mass boiler are at the heart of it. That converts more heat from the burner to hot water much faster and more efficiently than a tankless coil. And we also have heavy insulation to minimize losses. We also have a flow switch to respond quickly to any hot water draws. And we have a high performance mixing valve. So we have very, very stable hot water temperature production. That's also well known in the industry. So it's easy to service and maintain its operation. And then we also have a smart learning Ascent hydrostat. So the hydrostat is a well-known control in the US, and we added some smarts to that with some help from HydroLevel. And that allows us to add those smart learning modes that track usage patterns. Here are some thermal images of a typical tankless coil on the left. You can see how hot that boiler is. In fact, in the field, most tankless coil boilers can operate and maintain temperature in the summer of 180 degrees or even up to over 200 degrees, just to have the boiler hot enough to produce poor hot water. So you can see operation there and how hot the boiler looks in the thermal image. And then over on the right, you can see the Ascent Combi is a much cooler design. It keeps the heat in better and it transfers the heat much more quickly and effectively with a plate heat exchanger that really produces tons of hot water. Here are a couple additional pieces of information on the Ascent Combi. So again, 87 AFUE, it's conventional chimney vent, fires from 0.85 to 1.25 gallons an hour or 50 kW, and produces up to 4 gallons a minute of hot water or 15 liters per minute at 77-degree rise or 25 degrees C. Over on the right, we've got the Ascent Plus Combi, which is polypropylene sidewall or flex chimney vented. Again, it's non-condensing. And that goes up to 1 gallon an hour or 40 kW and produces about 3.3 gallons per minute or 12.5 liters per minute of hot water. I'd like to note also that there are ratings on tankless coils in the US, and the gallon per minute rating on those tankless coils is actually much higher than actual performance. It can be rated at 5 or 8 gallons. And it just provides a short burst of hot water, and then sustained output is very low in comparison to the 4 and 3.3 gallons per minute we show here, which vastly outperform the volume and temperature control. So here's an inside look at the combi boiler. We have a spiral boiler design, pretty unique design. I'll just highlight that we have a stainless steel alloy combustion chamber that allows us to have very good clean light off. And it's also it allows us to operate with no draft regulator. In the US, there's draft regulators that are used that can sap energy from the building as well. So there's no draft regulator required because it's very good, stable, clean combustion. But that chamber is also very good for biofuels. It gives us a very good operating characteristics that make it very forgiving for high blends of biofuels as well. The Ascent Plus Combi is a similar spiral, but we added another pass to it. So our flue pass is about 40% longer, so about 13 feet long. And then on this one, you can see up top, we have a dilution air fan. So we'll talk about that as we get into polypropylene next. And that one allows us to use outside air to dilute the flue gas temperature and bring it down. So it's a very safe temperature to vent with polypropylene, giving us a lot of flexibility on field installations. Here's a sample of our Resolute boiler, which uses a polypropylene vent. This was introduced in 2011. So we've been using this dilution air design for almost a decade now. And you can see how the outside air comes in. It goes down to feed the burner for combustion air. And it also blends with the flue products coming out of the boiler to dilute the temperature down and vent through polypropylene. The polypropylene temperatures on this may be between 130 to 170 degrees Fahrenheit. Let's see. So there are some challenges when we go to increasing efficiency, as we just talked about in the last session. The low stack temperatures don't provide good natural draft for chimneys, and condensation can damage the chimneys themselves. We could look at PVC as a venting solution, possibly. That's used for our furnace industry on natural gas, but it's inexpensive, but it only goes to 149 or about 65 C max temperature. And it's no longer code compliant in New York or New Hampshire. Boilers can operate with much higher boiler temperatures in the US, so there's no guarantee you could stay in those operating ranges in order to satisfy the temperatures required for hydronic heating. Stainless steel venting with AL29-4C is also an option that's good for condensing and non-condensing, but it's not easy to work with, and it's also expensive. So what we took a look at is the opportunity with oil heat. So without condensing, AFUE ratings get up to about 93, and oil heat's very good that way in the fact that we have less hydrogen in the fuel, so we don't have as much water in the condensate, so we can run at higher temperatures without condensing. Natural gas and propane condense at lower efficiency. So again, there's no corrosive condensate if you're not condensing. It's a very nice feature. Ultra low sulfur heating fuels mean that it's clean operation and very low particulates. I mentioned earlier that in the study from on integrated systems that we can actually outperform condensing boilers based upon annual efficiency of making heat and hot water with having low idle loss and properly designed systems. And based on that study, we even have better performance now with AFUEs that are up exceeding 91%. So with polypropylene, it actually makes it faster, easier, and more cost-effective for venting. So here's what it looks like for a typical hot water heater, a water heater rather. As I said, we took a page out of the water heater playbook. So this has been, dilution air has been used for venting water heaters for decades. We did the same thing. You can see in this case how flue gas goes into the bottom of the dilution air fan. Dilution air actually in this case comes in from the room, and the mixed flue gas goes out cooler. Here's how it works on this. I put this back up again because one of the questions I usually get on this is, well, what about cold climate? So we do our cold climate testing in Fairbanks, Alaska. And when we tested this out back over a decade ago, we did sustained operations at minus 50 degrees Fahrenheit or minus 45 degrees Celsius. The air gets very dry when it's below freezing out, and actually it dries out the flue products in this case. We've got many of these systems operating in this climate throughout the year as well. The polypropylene, here's a sample of the polypropylene. It's widely available and used in various sizes. This is Centrotherm, is a supplier for this. and European supplier, and with US presence as well. It's very competitively priced. It's rated up to 248 degrees Fahrenheit or 120 degrees C, so vastly exceeds the operating temperature ranges that we see. And it's very easy to install and service. If you ever have to go back and pull your vent system apart to take a look at something, it's a great design and very flexible for that way too. There's a locking ring on this. When this snaps together, it actually has over 100-pound force in order to pull the joint apart. So it's a very safe, well-sealed operation too. Here's a look at different polypropylene vented boilers that we have. So we talked earlier about the Ascent Plus combi that goes up to 1 gallon per hour. And we say that works for houses that use up to 2,000 gallons per year in a home. So it really satisfies 95+% of the homes out in the US. And this is the Ascent Plus, so that's a combi. So it's got a plate heat exchanger, instantaneous hot water. And then over on the right, we have 2 models, the Resolute RT and the 90 Plus Resolute. Both of those are very similar. One's the next generation model with Resolute RT, up to 1 gallon an hour, and again, 2,000 gallons per year for homes. The max vent length we use is up to 50 feet equivalent intake, plus an additional 50 feet equivalent exhaust. So very flexible, meets a lot of homes, very easy to find applications where this will fit and work well. Both systems have very attractive vent terminations. So we can see in the top left, a flexible chimney vent. And then lower left, we've got a low profile vent that with polypropylene as well, intake and exhaust. And then over on the right, we have a snorkel style vent with intake and exhaust. Again, the vent has to be polypropylene. The air intake can actually be PVC or polypropylene at the installer's discretion. Here's a look at the top of the Ascent Plus combi and Resolute RT venting system. So again, you can see cool dilution air comes in, it feeds down for combustion air straight down, and then going off to the right, it feeds and is diluted through the fan, or rather the hot flue gas is diluted through the fan, and then it goes out as vented gas that is cooler for venting and safe for operation that way. The savings that we look at on these systems for the Ascent Plus combi, even though it's a 91.3, we look at about up to 20% energy savings. And then over on the Resolute RT and the 90 Plus Resolute, we have a thermal purge control. So we actually not only heat when a thermostat calls, and when we're done, we purge the energy out of the boiler to the last zone that called. So we start and finish cold, and do the same thing with hot water using a plate heat exchanger and a special strategy on the hot water tank that works well for us. And so those can actually save up to 40%. I think this also highlights the fact that you can see both boilers on the Ascent line are, the Ascent is 91.3 and the Resolute RT is 91.3 as well, but we save up to 40% when we use a tank and a thermal purge versus only 20% if we use a combi boiler. So I'd like to summarize, I guess, the overall presentation with a few things. One is we can use proven technologies really to advance the liquid fuel reputation. We've got a great opportunity here. We can have better performance and a competitive price to satisfy consumer demand. And then on the policy side, energy savings can really reduce carbon emissions too, and be an added addition to what we can do with fuels. So we're going to really look at biofuels and future liquid fuels to compete on a source efficiency basis and provide a compelling pathway to carbon neutral future. So I think we've got a great opportunity there, and all these different technologies and fuels coming together and how we can make that work is really exciting for me as a manufacturer, and to see our industry really kind of taking a leading charge in that direction in order to solve the problems that we're facing today.